Okay, so we've talked about inverse functions and we've talked about inverse sine, and now we're going to talk about inverse cosine. So let's start by looking at the graph of cosine itself. So here's the graph of cosine, and we see that it does not pass the horizontal line test, right? That dotted horizontal line that's drawn hits it in more than one place. In fact, since cosine is a wave function, it would hit it infinitely many places. So just like we did with sine, we need to restrict the domain. Now we need to restrict the domain to a part where we'd hit all the range values, where we would hit all the y values between -1 and 1. So for cosine, what we're actually going to do is go from 0 to pi. So you can see there, as I've traced out in red, that hits all the values from -1 to 1, but it would pass the horizontal line test. And here you can see just that little piece. Okay, so that's the part of cosine that we're going to restrict to, that we're going to have an inverse on. So cosine inverse of x, remember the domain and the range switch. So the domain is going to be from -1 to 1. You'll be able to plug in any values, including -1 and 1. And the range is going to be from 0 to pi. So the values out you can get from 0 to pi. Now let's remind ourselves what an inverse function is. Remember, an inverse function kind of undoes the function. If you compose them, you get the identity function. Well, what does that mean? So cosine of x, we put in an angle and we get out a number between -1 and 1. And now inverse cosine is going to do the opposite. We're going to put in a number between -1 and 1, and we're going to get out the angle where cosine of that angle is the number. Okay, so we're going to go backwards. Now, in other textbooks or other places, you might see cosine inverse called arc cosine, and that just means the exact same thing as cosine inverse. So just good to know that they mean the same thing. Now we also should point out we'll be using the, we can use the unit circle for some of the values here. And since the range is from 0 to pi, we'll only be looking at angles in the upper half of the unit circle. So here's our way to find cosine inverse of values. So step 1 says set theta equal to cosine inverse of x. So if we're trying to find cosine inverse of square root of 2 over 2, we're going to say theta equals cosine inverse of square root of 2 over 2. Then it says rewrite theta equals cosine inverse of x as cosine of theta equals x. So we're saying for what angle is cosine of theta equal to square root of 2 over 2. Now we're going to use this unit circle between 0 and pi, and that 0 and pi is really the critical part. That's going to be the upper half. So the upper hemisphere. To find the value of theta that satisfies cosine of theta equals x. So we're going to use the unit circle, and we're going to say on the upper half, what angle gives us that cosine of that is square root of 2 over 2. Now remember, cosine are the x values. So we're saying where is the x value? Square root of 2 over 2. So let's go to our unit circle. So here's our unit circle, and sorry it's getting cut off a little bit here, but we can see the important one. Our x value right here is square root of 2 over 2, and that's 45 degrees, or pi over 4. And you know, you can either give these in radians or in degrees. So we can say, okay, theta would equal 45 degrees. Okay. Let's look at B. We're saying, okay, what is cosine inverse of -1/2? So we'd say, okay, theta equals cosine inverse of -1/2. So we want to know where is cosine of theta equal to -1/2. So we're going to use our unit circle again. Oops. And we want to know where is the x -1/2, which is right here. So that would be at 120 degrees. Now, I should point out that it would also happen here at 240 degrees, but that's not in our upper hemisphere. So we're only, even though it'll happen more than once, we only want the angle where it's up in this top half between 0 and pi, or 0 and 180 degrees. Okay, what's cosine inverse of 0? So we'd say theta equals cosine inverse of 0, which means cosine of theta equals 0. So where is the x coordinate? 0 on the unit circle, and that happens at 90 degrees. Okay, or pi over 2. And then one more, here we'd say, okay, theta equals cosine inverse of -4/3. So we'd say cosine of theta equals -4/3. Now, if we try looking on the unit circle for -4/3, we're not going to find it, because -4/3 is a number less than -1. It's -1 1/3. And so this does not exist. Or you could say undefined, because -4/3 is not in the domain of cosine inverse. It's less than -1.